Welcome, welcome, ladies and gentlemen, here at the Hannover Fair of 2023. We are here at the Hydrogen and Fuel Cells Europe, and you sit at the technical forum where we are listening to presentations from experts in the field. The next presentation on stage will be about the future value chain of PEM fuel cells and PEM electrolyzers, and we'll look at that from a production point of view. I'm happy to introduce our next speaker. And our next speaker, he comes from the Fraunhofer IPT, where he is a research associate. So welcome on stage, Martin Aretz.
Hi.
The stage is yours.
Perfect, thank you. Thanks for the nice introduction. So as you already said, my name is Martin Aretz. I'm a research associate at Fraunhofer Institute for Production Technology. And as the name says, we are focusing on the value chain and production challenges and issues on different production-related issues. So, over there, I'm sorry. So, we are based in Aachen in the production cluster view. So that means we have a strong university background, a strong scientific background. We work together with the WZL in Aachen, so that's one of the biggest institutes for production-related issues. And we are close to the production engineering cluster, where we face issues about the production, not just for fuel cells, for electrolyzer, or for the hydrogen economy itself, so for a lot of different topics. I would like to focus, of course, as the name of the presentation today says, about what we do about the production for fuel cells and electrolyzer. So we're facing these challenges in a lot of different ways. So first of all, we look on the machine and the tool construction. So we say, okay, what kind of machine and tools are actually needed to ramp up and to scale up the production for the different components, such as the bipolar plate, as the membrane, or the tanks for the hydrogen economy. So the products, as I said, we are facing are mainly focused on the stack components. So all these components we need to produce in a highly scalable manner. Just imagine if you have a fuel cell with about 350 cells, we talk about 700 bipolar half plates you need to produce. Just imagine you have 1 million fuel cell cars, imagine you would like to produce. We talk about 700 million bipolar plates in a really precise way you need to manufacture. And what we do in there, so we start on a holistic view. Then we say, okay, what are the demands? What's the market perspective on the production point? We have a look on the technology, so what kind of production technology is available for the different process steps, so instance for the cutting, for the forming, for the coating, and for the welding of the different plates, staying with the example of the bipolar plate. But we go down as well on the really deep dive level, so that we have the prototypic production and that you as a customer can work with us together to design your own stack and your own component designs. So we do that in the business unit of energy storage systems at Fraunhofer IPT for the fuel cell on the one hand side and for the electrolyzer on the other hand side. We started some years ago with the fuel cell and had a look on, as I already mentioned, the bipolar plate, the gaskets and the membrane electrode assembly, and shifted then because there are a lot of similarities in the parts and the structure of the electrolyzer and the fuel cell, looking on the PEM electrolyzer for now and shifting that now on the alkaline and the anion exchange membrane electrolyzer as well. So there are a lot of similarities in there, but as well we have a lot of differences in terms of requirements, about the pressure, about the sizes, and about the production volumes itself for these different systems. So I'm in integrated production machinery department, and we, as I say, look on the whole value chain for the fuel cell and the electrolyzer. So that means what do you and what do we need to do to come from our raw product, so for instance from the stainless steel or for stainless steel, from raw material to your finished plate. And we don't look just on one single production step itself, we look on the interdependencies between the different production steps. So what do you need to do in production step one? What kind of requirements do you have to fulfill the requirements of the next step or the next step, the production step afterwards, that you get your finalized product in the end. So why are we doing it? I think the whole booth here is just about hydrogen, about fuel cells, about electrolyzer, of hydrogen combustion and the whole hydrogen economy. So the reason for that is pretty simple. So when we, from the one hand side, look on the scale up or the fuel cell cars, we are expecting about more than 2 million sales and fuel cell electric vehicles in 2030. So if we are looking on the chart on the left hand side now, we are about in 2023 right now. So that's a strong increase in production volume needed to fulfill these goals for the main markets: China, Europe, Japan, South Korea, and the US. On the other hand side, on the electrolyzer business, we don't talk so much about cycle time. We don't talk about its numbers itself. We normally talk about gigawatts and megawatts that are needed, which we actually can break down afterwards in needed production volumes for your single components, such as the bipolar plates, the membranes, and all the components you need to have your finished electrolyzer, the alkaline PEM in the end. So in there, we talk normally about cycle times about 10 seconds per part, and we have a high flexibility in the design and the product architecture. So what we see on the electrolyzer side, so we have a lot of different designs that leads to different requirements and different kind of production technologies which are exactly needed for the ramp up. And we have on the other hand side the fuel cell, which is more or less highly standardized for now, but where we need cycle times because of the high production volume of about 1 second per part. And just imagine you need to produce one part every second, so that's from the production point of view quite a challenge. So we face that at Fraunhofer IPT together with our colleagues from other Fraunhofer institutes, together with industry, with industrial partners who would like to go into the hydrogen business and the production of these single components. But we do that as well in big research project with a scope of 3 or 5 years, where we have a, let's say, wider view into the future in terms of the production technology. And one of our main research projects now is the H2Go project, funded by the German government, where we have a look on every single production step and, let's say, phase in the production line for the fuel cell component. So that's the fuel cell set right now. So that we in the end have a one industrialized process chain for the high scalable, low cost production of the fuel cell components for the bipolar plate, what you see here, and for the MER. And we do that in a Fraunhofer consortium based on a lot of different the knowledge we have in the different Fraunhofer institutes. So that means we have a lot of experts all across over Germany, and we use the expertise of these experts really well, so that not one guy does everything, so we stay the competence where it is right now. Yeah, that's what I just said. So we have about 9 federal states involved in this project. We have about 18 Fraunhofer institutes working on this 4-year project in total, where we define, set up, and operate manufacturing lines for the large-scale production of PEM fuel cells for the future. Coming from the fuel cells back to the PEM electrolyzer. So another project we are facing right now is the H2 Giga project in there, where we talk about the Referenzfabrik. That's the German name for that. That's the reference plant architecture, I would say, translated in English, where we do the same for the PEM electrolyzer production, together with other Fraunhofer institutes as well. So where we challenge the production of the PEM electrolyzer, like the high flexibility, the high differences in the product architectures, and the demand for the single technologies. Within that, the project is a little bit smaller. We have a funding here of 20 million euros for the investments to really develop these technologies on stage. So that's not just theoretical and concept knowledge, so that we actually can produce by ourselves the single components. So we started in there with designing a reference architecture for the PEM electrolyzer, so that we have a reference stack, and where we face all the production-related issues for the high-volume production in there, and that we can iterate based on the standard design. And all these knowledge we gain in this research project face in, my colleague yesterday already proposed it to you, in this reference factory. So the overall goal is that we build up kind of a technology kit of the different production technologies. So facing, as we say, we have for every process step different opportunities, for instance, to form, to weld, and to coat our bipolar plates or our components itself. and that we can benchmark the different production technologies and process technologies for the different use cases for the fuel cell and the electrolyzer business. So it's all about transferring the knowledge from the big research projects into, let's say, one knowledge box. The second thing we do in there is offering services for the industry. So, for instance, having partners which are facing just one technology step, that we can look on the whole value chain and can offer, okay, we do the steps beforehand and the afterhand, and that we have the whole value chain covered for our single customers. The third, and maybe the most important idea, is the platform character of this reference factory, where we say, okay, we have the possibility to connect the different partners in the value chain. So the manufacturer for the steel, for instance, with the forming specialist, with the coating specialist, so that we have the creation of this value chain on hand, and where we can work on the different production technologies within the experts in the several fields, always with the targets of increasing the flexibility of production for different product architectures, for the electrolyzer, increasing the speed in production so that we're facing this 1 second per component or these 10 seconds per component for the different components in there, and that we reach kind of a visibility for the whole production environment for fuel cells and electrolyzer and increase the competitiveness of this whole consortium in there. So we are located here in Hall 13 and booth E9, so that's right there at the entrance of the hall. We are really happy to answer your questions here, and we will be here until the end of the fair tonight or to this evening at 6 p.m. And we are happy to answer your questions there and now as well. Thanks, everybody.
Thank you very much for the nice talk, Martin. It was really interesting to learn, and I think you're doing like really an important job and crucial work regarding the whole scale-up that we've been discussing, and it's been a big topic here on the fair. When you look around, we are at a point where we need to scale up, and we need to do that in a really short amount of time. So thank you very much for the work that you provide. I want to give the chance to the audience in case you have any questions. We have time for one question. Otherwise, I have a question for you. I want to look a little bit behind the technology because I think coordinating such a big project with so many partners is a tricky endeavor. So can you tell us a bit more? How do you bring them to one table? How do you make it possible that you're speaking the same language and moving in the right direction together?
Yes, of course. So like these big projects, a lot of people are working on there, and what you just mentioned, that we have the same language, so that normally starts that we have the kind of a reference architecture or definition of the different, okay, what we are actually talking about, so that we actually talk the same language is the important first step. And then afterwards that we focus this directly say, okay, what kind of overall goal do we have in this consortium? So that we know, okay, you with your expertise in coating, for instance, in forming, in the material business, that we all know, okay, the overall goal is to produce that reference stack and learn in our different process steps what we need to do to fulfill the requirements and goals of other partners itself as well.
Thank you very much.
You're welcome.
So one last applause.
Thank you.
And I hope to see you again next year, and for everyone else, you can meet them at the booth.
Bye, everybody.